All right, today we're going to take a deep dive into the architecture of the AdventureTube platform. So, what's the big deal here? Well, this is a complete microservice system, but it doesn't live in the cloud. Nope, it runs entirely on the edge. So, here's our game plan. We're going to start with the software itself, the distributed microservices. Then we'll get into the really unique part, the hardware it all runs on. After that, we'll see how automation and event streaming tie everything together. And finally, we'll wrap up with how the system is monitored and what the key takeaways are from this awesome edge architecture.
Okay, so this whole architecture really stands on 4 core pillars. Let's break them down.
And here they are, the foundation of the whole system. First up, you've got your distributed microservices. That's the brains of the operation, handling all the application logic. Then you have the edge hardware, which is where all this software actually lives. In this case, on Raspberry Pis. To make sure all those services can talk to each other, there's event streaming. And finally, to keep it all running smoothly, you have automated operations. All right, let's kick things off with pillar number 1, the application layer. We're going to dig into how these services are designed and how they handle all the different kinds of user traffic. Okay, now this diagram shows a really clever design. See how all the traffic comes into that single gateway? From there, it splits into 2 totally separate paths. On the left, you've got the authenticated flow. This is for writes, user operations that need to be secure. That path goes through the auth and member services. But on the right, you have the public flow, which is for simple read requests. It takes a much lighter path through the web and geospatial services. This separation is absolutely key for performance and for security. Drilling down a bit, this table shows the actual tech stack for each service. And this is a classic microservice approach, right? Using the right tool for the right job. You can see the gateway and all services are using a high-performance, non-blocking stack called Netty, which is perfect for handling tons of connections at once. The other services, though, use a more traditional MVC approach with Tomcat, which is great for standard business logic. And it's all backed by 2 different databases, Postgres for structured user data and MongoDB for the more flexible geospatial data. So, we've seen the software, but where in the world does it actually run? Let's move on to pillar 2, the hardware edge. And remember, we're not talking about some big data center here. This is all on physical devices. Believe it or not, the entire platform runs on this 3-node Raspberry Pi cluster, and each one has a very specific job. You've got Pi 1, the heavy lifter, which handles all the storage and monitoring. Then there's Pi 2, the application brain, which is where the core microservices actually live. And finally, Pi 3, the lightweight edge, which serves up the public web traffic and helps out with deployments. This side-by-side view makes that workload split super clear. Just look at Pi1 on the left. It's running 16 containers, but they're all for infrastructure stuff, databases, monitoring, CI/CD tools, you name it. Meanwhile, Pi2 on the right is laser-focused on the application itself, running just 11 containers that handle all the business logic. It's a really clean separation of concerns, even at the hardware level. Okay, let's talk about the platform's nervous system, automation and events. This is how data flows between services, and, just as important, how new code gets from a developer's laptop into the live environment. So here's a look at the data layer. Along with the standard databases, the system uses Kafka for event streaming. And what's really cool is that it's running in what's called KRaft mode. Now, the key thing to know about that is it's a modern approach that gets rid of an old dependency called Zookeeper. That makes the whole setup simpler and way more efficient, especially on this kind of hardware. Think of this Kafka cluster as the central message bus for the entire system.
And check out how automated the deployment pipeline is. It's beautiful. So a developer just pushes their code to GitHub. That push triggers a webhook, which kicks off the Jenkins automation server on Pi 1. Jenkins then tells an agent on Pi 2, hey, go grab the new code. The agent pulls it, builds it, and deploys it using Docker. The whole thing is completely hands-off, a seamless flow from code right into production.
Now, security is handled really cleverly here. You never, ever store sensitive stuff like passwords or API keys in the code repository, because that's a huge risk. Instead, they're kept safe and sound in a secure vault inside the Jenkins server. Then, during the build process, they get baked right into the Docker image, and at runtime, they're injected directly into the application's memory. This is so important because it means secrets are never written to disk or show up in any logs. Okay, a system this complex needs really solid monitoring, right? So for our final section, let's dive into observability and see exactly how the platform's health is tracked. And this is not just some weekend hobby project. It has a full enterprise-grade observability stack. You've got Prometheus scraping metrics from all the nodes. You have Grafana for building these rich, detailed dashboards. Zipkin is there for distributed tracing, which lets you follow a single request as it jumps across multiple services. And finally, Portainer gives you a really clean UI for managing all the containers running across the cluster. So let's just recap the highlights here. We're talking about a true distributed microservice architecture running on ARM Edge hardware. We have a secure get-back to configuration process with slick credential injection. We've got modern Zookeeper-less event streaming using Kafka. And the whole thing is locked down with SSL encryption across the board. Yeah, this is a serious setup. So what's the big takeaway from all this? Well, this entire project really serves as a powerful blueprint. It's proof that you can absolutely build robust, complex, enterprise-grade applications on the edge, completely outside of the traditional public cloud. What this project really proves is that things like event-driven architecture, secure CI/CD, and full observability can run super efficiently on low-cost ARM hardware. This opens up a whole world of possibilities for applications that need local processing, low latency, or need to keep data in a specific location. So the question I'll leave you with is, what kinds of problems could you solve with an architecture like this?